All right, so we'll get going. Thank you everyone for coming to Diana's thesis, master's thesis defense. So I met Diana last January, January 2024, and I was so impressed with her drive and her excitement and just her whole ideas of thinking about science. And she developed this project essentially on your own, looking at soil health and thinking about building on her undergrad degree in agricultural sciences, but moving more to a wildland setting. And it's been so exciting to see her progress through this master's work and see just how much she's grown and how well she understands. And you're going to see this today in her presentation. So I'm so excited for Diana to go. And so the way that today is going to happen is Diana's going to give about a 30-minute presentation, and then we'll open it up to questions from everyone who's here online as well as in the room. And then we will say thank you for coming, and she will meet with her committee, me, Dr. Garrett Lyle, and Chrissy, and we will ask her some additional questions, and then that will be the end. Sound good? Or the beginning, yes. Exactly. It'll be the beginning of life. All right, take it away. Yeah. I'm like the beginning.
Hi, as Kristen said, I'm Diana Madrigal Kemp, and I will be presenting my thesis. Well, actually defending today's my defense, but it's part of the Wildland Master's program. And Kristen introduced my committee already. Kristen is my chair. And the title, originally I just had Wildland Management Effects on Soil Health, but I changed it so it's more descriptive instead of just soil health. So I made sure I did Wildland management strategies in California oak woodland ecosystems or soil health ecosystems. And moving to the next slide, I'm jumping right into it. So it was working.
It was.
Well, I will stand right here, I guess.
If you want me to do that, I can do that for you.
I think you have to do it from your computer.
Okay. Oh, nothing's working now. Okay. So I will be looking at, I'm looking at the background, like why is soil health important? Why does it matter? So California's oak woodlands are among the most biologically and culturally significant ecosystems in the state. It supports native plants, wildlife, carbon storage, and has a long history of indigenous stewardship that helped shape the fire adapted ecology in the system. These systems evolved with frequent low-intensity fires that maintained open understories, healthy soils, and species diversity. Soil health is the supporting foundation of every function of oak woodlands. It regulates water, stabilizes slopes, cycles nutrients, buffers pollutants, and supports vegetation recovery. As fire regimes change, land managers intervene. Understanding soil response is critical to ensuring long-term ecosystem recovery. So can you just click on this? So over the past century, fire suppression, conifer encroachment, and climate change have drastically altered these landscapes. The result is dense, overstocked forests with accumulated surface fuels, making them highly susceptible to severe wildfires. To combat these issues, land managers are utilizing different fuel reduction methods to prevent wildfires from destroying these valuable ecosystems. The problem is that most management methods evaluate the success of fuel load treatments by looking at vegetation recovery without looking at the impacts of soil. I recognize the gap on how fuel treatments are assessed. Soil response is often overlooked. This led me to examine soil health side by side with vegetation recovery to better understand how treatments influence the long-term resilience of these woodland ecosystems. Next slide. So a question that I struggled with a lot in this system was, what is soil health? Especially when you're discussing an ecosystem that needs disturbance. So I found just a traditional definition by Doran and Sees defines this soil as a living ecosystem that supports plants, animals, and people. But throughout my study, I found that oak woodlands support soil health differently, and it's better defined as the capacity of the soil to sustain and support ecological functions through disturbance. This study challenges traditional static definitions of soil health by illustrating that in fire-adapted oak woodland ecosystems, soil health must be viewed as dynamic, treatment-responsive process. Management actions, vegetation feedback, and the sequence and intensity of disturbance over time influence this entire process. I developed this definition through a combination of field sampling methods, lab analyses, and statistical modeling. So the study was conducted in oak woodland habitat located in Loafer Creek Recreational Area. This area is managed by DWR and California State Parks. And these soils consist of Dunestone, Loafer Creek. They are clay loam and are well drained. So I had a total of 9 units in this site. Each contained 3 transects, which you can see, or 3 plots, which you can see in the red throughout the units. And each plot had 3 transects within the red circle, and there were different treatment types. And I just was guided by the treatments based on where the fire was going, what we were doing, and when we were going to get a fall burn. It changed regularly. So you can see untreated in the orange. It means no disturbance, and I used it more as my control to compare other treatments within the units. And then you can see in yellow, while it's the wildfire plus mastication plus RX burn, and it was impacted by the North Complex fire in 2020. And it's our post-wildfire recovery unit that was masticated and later treated with prescribed burns. And then you can see here in the purple, it's mastication only, and this unit has only been thinned by the use of heavy machinery and has not had any fire treatments. And in the pink, you can see here, this little one, that is my Hampton plus 1 prescribed burn. And this unit has been manually thinned and received its first prescribed burn entry in the fall of 2024. And then the blues have received more treatment. So it's Hampton plus multiple RX burns. So they've received more than 1 fire within its landscape. And they've been Hampton, no use of heavy machinery. And the purpose of the study was to assess how fuel reduction strategies and fire history influence soil conditions, nutrient cycling, and nutrient recovery. So like I mentioned, I had my plots that had the red circle, but within each plot, there were quadrant-based soil sampling and vegetation collection. So in order to achieve this, I had that midpoint and I had a 0.5 meter squared quadrat. And it was established at the center of each transect line. And within each quadrat, measurements and samples were taken. Vegetation and ground cover were assessed using the line intercept method. And soil chemical properties were analyzed using rad lab methods. And the carbon nitrogen was sent to waypoint analytical. For my statistical approach, I used R statistics. I conducted one-way ANOVAs, and I looked at effect size within each significant treatment. I looked at 2 key HSDs, and mean values with standard error were in my graphs. And then to see the bigger picture, I did the PCA, which is the principal component analysis, and I'll discuss this further as we get along. And now I'm going to talk about my ground cover significances and what I found. So according to a study conducted by Holzen and Alan Diaz, grasses and forbs account for 80% of the ground cover in oak woodlands, influencing soil moisture and nutrient cycling. But does more grass always mean healthier soils? Well, mastication had a significant treatment effect, but it increased in 2025. You can see there were more grasses in 2025. You can see in 2025 is the darker grays, lighter grays, 2024. The only treatment that increased in 2025 was wildfire plus mastication plus RX burn. Both of these treatments, mastication and wildfire, did not get a fall 2024 treatment fire. We didn't apply prescribed fire to it. While the treatments that received a fall prescribed burn, you can see a decrease from their original 2024 to 2025. You see that decrease. And it's expected. Fire came through and I sampled again in February. So we didn't see a lot of grasses regenerate from that time. But this is exactly why I argue the soil health must be defined as dynamic treatment responsive process. Treatments affect the system differently over time. Some push the system forward, some stall it, and others like Hampton plus one RX burn may even cause temporary setbacks when you look at the data. Like picture this, the untreated plot, stable, dense, unmoving, grass cover barely changes, no disturbance, but also no recovery. Now compare those plots to the ones that have been burned or thinned or were masticated. You can see them shift, sometimes moving, sometimes struggling, but always moving and showing changes. That's the kind of system that's responding, and that's what makes soil health visible. So now let's shift our focus to what threatens these oak woodlands. So according to a study conducted by Stafford and others, woody plant encouragement threatens biodiversity, ecosystem function, and fire-adapted landscapes. In the absence of fire, shrubs and trees expand, altering microclimate, water availability, and soil processes. In my study, the largest reduction in woody cover occurred in the Hampton plus multiple RX burns treatment, which dropped from about 7% in 2024 to roughly 1% in 2025. This was the only treatment that showed a statistically significant year-to-year decline determined by ANOVA. However, the effect size was small, and it explains the small little asterisk on the bottom. In 2025, Hampton plus multiple RX burns had the largest treatment effect size, while treatments that included Hampton and mechanically thin only experienced a significant reduction compared to untreated. Because there were treatments that didn't get a fall burn, their woody cover remained unchanged from year to year, but they were still different from one another when compared to the untreated ones. You can see mastication only also has a large treatment effect on woody vegetation cover in both years. These results emphasize that interference is necessary and effective in reducing woody vegetation which poses a threat to soil health. This type of vegetation burns hot and can cause harm to the soil structure, and it can leave the soil surface exposed with no protection. Next slide. And then I decided to look at the structural part of it. This is one of the components. I did other structural methods, but I wanted to talk about compaction because it reflects the physical properties that treatments place on the soil. It can reduce infiltration, restrict root growth, and delay the return of herbaceous vegetation. In my study, mastication only and wildfire plus prescribed burn and mastication had the highest compaction in both years. Even though the wildfire came through in 2020, the impacts are still there. When the fire hits these landscapes, land managers are left with a mess and they have to clean it up and figure out a way to do it. And sometimes that means making multiple passes with having machinery in the same area to reduce these surface fields that have accumulated, even though a severe wildfire came through. And after that, they utilize the prescribed burn to clean up the leftover material to reduce the hazardous material that's left on the ground. The goal is to make space for grasses and forest return and prevent woody vegetation from taking over the landscape. But they compact soil, so it's better to intervene before the fire comes through and you see it less of an impact in your landscape. And that's what treatments are supposed to do. They're supposed to create less of an impact and mimic natural processes that occur in the system. And you can see different outcomes in the systems. You can see Hampton plus 1 RX burn plus Hampton plus multiple burns showed a decrease in compaction over the years. This matters because it shows that thinning crews can increase compaction at first. So you see that, especially in Hampton plus 1 RX burn, because there is a significant increase, but after the prescribed burn, it's reduced. You can see it in FOD that had multiple treatments as well. There's less fluctuation too, like you don't see that much of a drop than you do in Hampton plus 1 RX burn. This you can see this, and compaction levels here get closer to untreated. So you can see here they're getting closer to the same standard mean as untreated units, which have had no disturbance within its landscape. And this shows how treatments interact over time. Some keep adding pressure to the system, others begin to relieve it. It also shows how being proactive helps protect your soil from compaction. Once I saw compaction decreasing, I asked any question. Was the soil actually recovering or was it just less compacted? To explore that, I used carbon to nitrogen ratios to track nutrient balance. In oak woodlands, healthy soils, according to Aikenhead and McDowell, range from 12 to 25. This range supports balanced microbial activity and nutrient cycling. However, Gomez, Ray, and others found that soils receiving high CN inputs from shrub and litter can still support active nitrogen cycling. This means CN ratios is a useful indicator, but it's not a fixed threshold. In 2024, the highest CN was observed in untreated plots. All other treatments were lower. This includes mastication only, wildfire plus mastication plus RX burn, and both Hampton treatments. ANOVA comparisons revealed that Hampton plus multiple RX burns were significantly lower than untreated, but the effect size remained relatively small. By 2025, the pattern shifted. Hampton plus 1 RX burn spiked to the highest value recorded in the study. And this is the value that I got close to 1, which means the biggest treatment effect. And you can see it in the Hampton plus 1 RX burn. The first entry burn significantly reduced or increased carbon nitrogen balance. Mastication only plus wildfire plus RX burn also increased. Hampton plus multiple RX burns remain low, was again significantly different than the untreated unit. These shifts show how timing intensity influence soil nutrient dynamics. A low CN suggests nitrogen might be readily available or decomposition is rapid. A high CN might indicate nitrogen immobilization or pulse of carbon, fresh input of carbon, which can be explained here because we had that burn. You can see this is actually during the prescribed burn, and you can see some of the woody vegetation coming in, and you can even see it kind of creeping up to the canopy. So that could explain why you're seeing that high carbon load in the system. Also, high levels of litter and dust can be found in areas that are undisturbed. But Hampton plus multiple RX burns suggest repeated burning help maintain nitrogen availability. Even though it's slow, you don't see that crazy fluctuation within the system. So now moving forward. So this is my PCA graph. It looks crazy, it's jumbled. I'm going to try to explain it the best way I can. So we're just going to start with the basics before I get into the data. So this graph shows soil, vegetation, and structural change together across treatments. This principal component analysis, PCA, simplifies complex data by reducing many variables into 2 main axes, and it shows you in what direction those variables pull it. So you have PCA1, which is here, and then PCA2, which is there, and they're on both sides. This is 2024 PCA, and this is 2025 PCA. PCA1 shows the direction that explains the most variation in the data, while PCA2 explains the second most The percentages next to each axis show how much of the total variation each axis accounts for. Each point on the graph represents a sample plot. Plots are closer together, have similar conditions, and plots that are further apart have different conditions. The arrows represent sample variables for this study. There are other variables, but I selected the top 10 key variables that show the biggest pull within the system. So I can easily explain this, well, as easy as I can explain this to you guys without it being too messy. The length of the arrow shows how strongly the variable influences the overall variation. The direction of the arrow indicates which axis the variable is most associated with. For example, the area variable of the arrow is tightly associated with PCA1. You can see it more like horizontal, and that variable is closely tied to the variation explained by PCA1. It points, if it goes up or down, moves slightly, it's slightly more associated with PCA2. PCA helps show where treatments move in relationship to each other and the variables. It combined multiple indicators to show broader recovery patterns. So you can see in Hampton plus 1 Rx burn, here it's in red, and in 2024, plots were near litter and low vegetation in that first year. The pattern reflected thinning without fire, and fuels remained on the surface. By the second year, the treatment still stayed near, the second year, we're looking at 2025, stayed near litter and dust responses. This indicates that a first century burn does not shift the system to being influenced by nutrient components, but rather shows that an entry burn can cause stress on trees, leading to litter accumulation, which I noticed after a prescribed burn. We saw the leaves dropping to the ground, and you can see that influence of litter. And when I went in February, it was you can see just how much tree canopy stress there was here. Hampton plus multiple Rx burns, and the olive plots remained near nutrient variables in both years. They became more tightly grouped after time has passed from the prescribed burn. So you can see them like really tight here, but then once you get to 2025, they start separating from one another and move towards nutrient and vegetation indicators. And then untreated plots stayed aligned with structural indicators like depth and compaction. They're in the blue. They showed little movement over time, like when compared to what variables pointed in what direction. They separated from one another in 2025. So you see changes occurring, but they're still being influenced by, similar structural variables. Plots impacted by wildfire, followed by mastication prescribed burning in pink, showed mixed results. Some moved towards nutrient indicators, while others remained scattered. This reflected the range of outcomes following high intensity disturbance and follow-up treatments. Overall, PCA supported the finding that fire, especially when applied intentionally, more than once shifted the system towards recovery. Treatments and vegetation response moved more towards nutrient availability, and treatments with one entry burn remained near structural conditions. Recovery occurred when treatment supported both fuel reduction and vegetation responses. So, go to the next slide. So, what does this mean? And you'll see these pictures. I'm going to summarize how what I found from my treatments just from the two samples. As we know, it's dynamic. It's going to change. It's going to fluctuate. It's going to get better or worse, depending on when you sample and the time you sample. But you can see wildfire plus mastication here. And there's Kristen for like a size comparison of the floor suite. That gets really tall. You can see here that it's just an ugly landscape to me. It's my least favorite one. But wildfire removed canopy and surface layers, leading to increased herbaceous cover. And since you see all this horseweed is disturbance adaptive. It's native, but it tends to come into areas that have been impacted. Compaction, there's higher compaction due to post-fire mastication. when I sampled them, I looked at litter and dust. There was minimal litter and dust, and more exposed rock and mineral soil in these areas. But year 2, some plots showed increase in nutrient indicators, but responses were inconsistent. So untreated plots remained the same. The only thing that changed was that I didn't bring something to hold the sign up. But you can see canopy and woody cover stayed high. Herbaceous plants remained low, showing little understory development. You don't see like the high grasses. They all look pretty much similar. You see some forbs coming up. We can't see them here because the grass got so tall. The litter build up over time, which is expected. Nothing's happening to disturb those surface layers. And it increases fuel load. So if fire were to come through, it's giving it more fuel to keep going and destroy this landscape and make it look like the previous landscape I showed in the first picture. They remain stable because nothing really changed, but what is stable, you know? And the plots remained without a sign of disturbance. They showed no movement towards nutrient availability or vegetation response. And here for vegetation or for mastication only, mastication reduced the overstory. So you can see in this area, there's more space between the trees. Further back, it has yet to be treated. And you're seeing like more of a dense canopy overstory. And fuels seem to be distributed. I can't talk right now, but they're moved around the soil surface, which leads to an accumulation of woody material. And soil compaction stays high throughout both years. And it's expected you have this big piece of equipment coming in and knocking down trees, the trees fall, you know, there's impacts happening from the trees and the heavy machinery. And herbaceous recovery was delayed. As you can see, there's all this wood, so things don't really want to grow through that. There was some increase in vegetation ground cover, but it wasn't anything big or significant. It was minimal. And so for hand thinning plus 1 entry burn. So here you can see it in 2024. This was before the fall burn of 2024. And you can see how there's a lot of grass, and it reduced the canopy and allowed more light to come through. Surface fuel stayed in place. Litter increased after fire, most likely due to stress. And first entry burn increased CN ratio. Plots remained tied to structural values, showing that thinning plus 1 fire treatment was not enough to move the system. And then we have hand thin plus multiple RX burns. Again, hand thinning, you know, opens up the canopy, and repeated fires remove surface fuel. Herbaceous cover increased both years. Soil compaction stayed low. CN ratios didn't fluctuate as much. There were any giant spikes after the fall prescribed burn. This treatment had the strongest and stable vegetation and soil indicators, and repeated fire supported above and below ground recovery. So I started this presentation by defining soil health as the capacity of the soil to function as a living ecosystem. But California's oak woodlands, that definition needs to go further. These ecosystems evolve with disturbance, fire, thinning, and recovery are part of their cycle. In this context, soil health is not about returning to a fixed state. It's about whether the soil can continue to support ecological functions as treatments are applied and conditions change. So this study showed that soil responds differently depending on the treatment. Some treatments cause short-term disruption, but support recovery over time. Others appear to be stable but stuck, like untreated. What I found is that soil health in these landscapes is dynamic. It's dynamic. It changes with disturbance. It recovers through cycles, and it plays a central role in whether vegetation can return, nutrients can cycle, and fire can be reintroduced safely. No, sorry, I just looked up at you. You go back. I'm not gonna look at you, or else you're gonna change my slide. I don't know how to get it. Here we go. Well, you ruined my picture for the surprise thing.
Listen, pictures have been amazing all the way around.
Yeah.
I didn't have pictures originally, and Kristen was like, maybe you should have pictures, something that you like, you know? Or show a meaning instead of just graphs or ANOVA tables, which I removed the ANOVA tables and added awesome pictures instead. This, if we did, okay, I already said this. This work shows that fire adapted systems require fire-informed soil management, and the lasting resilience depends on how, when, and how often we intervene. Now you can go. I want to say thank you to all these people shown here. Christine, you put fire on the ground. You're doing amazing work, and it's stressful, and you're always out there just putting in the work, and you're proud of it. Kristen for supporting me. I couldn't have done this without her. Joe was there every day, even after he lost part of his finger. So I'm really happy to have him and have him be a supportive husband. Garrett Lyle has been always constantly encouraging me. Like if I'm stressed out or something, I can call him. Well, I have called him one time and I was just like, I don't know what I'm doing. And he's like, you got this, it's all good. Like, you know, you've done this, you know, science. And Mikkel Bryant, his CSE squared student, came out and helped us that first sampling trip. Well, it was 2 sampling trips. She showed up. She was awesome. And my parents, because they made sure they were there, they made sure that I got stuff done in time to be able to graduate, and I didn't prolong the sampling process. And some references here, and you can move to the last one. And that concludes my presentation. I'm open for questions. Or something.
I was thinking about that too.
Oh my God.
Turn into a desert in your mouth real fast.
It's a lot of words.
A lot of words. Too many. Sometimes I can't say them either. Oh, Kevin?
So you phrased it as far as fire coming in and acting on these ecosystems. Use the term like destroying them. And so like in your words, like what does it mean to destroy like open?
When it has no canopy or any mosaic or diversity, you can see it. So where I meant more like destroy them would be like wildfire impacted spots that I sampled, because if you look at them, where are the trees? You just see like some sticks or popping out of the ground that look like they've been torched, and you don't see that like vegetative variation either. You have shrubs that are about the same size as your grasses, and they're all in the same like age structure. They're not taller than the grass or developing, but then you also have the issue where like if you don't do anything, you're going to get all the shrub encroachment, and that's not good either, because it's just going to be a cycle that repeats itself. You're going to get additional wildfires that are going to destroy the system. It's not about destroying the system, it's about introducing change. So if you intervene, then you can come in and see that change, even if first century fern looks like it got destroyed, as you saw in that picture. If you want, can you go back to that slide?
Remember, I can figure out how to go back.
Like, I'm not touching this.
I was just curious, it seems like there's a conservation aspect in what you're doing.
Yeah,
You
there-
want these ecosystems to disappear.
Yeah, you want to intervene to protect them, especially since they're so limited. You know, you see development, and when people look at this, some people don't see value in conservation. They're like, oh, we can build a house here, or we can build something here. And they don't really care about protecting them. But then you have people like Chrissy, who like is proud, wants to protect them, and tries to intervene in some way. And these are in the same location, but like first century burn looks like it completely destroys everything. But then Chrissy sent me, when did you take this picture?
I took that like 2 weeks ago.
So I showed her this picture. I'm like, hey, do you have a picture? 'Cause I had to go back out to Loafer Creek in Unit 9. And I'm like, I sent her this picture, I'm like, because this is all I have, and it doesn't look like it's really doing anything for the system. And, she's like, oh, no, it looks totally different. You can see all the grasses coming in. You see that, that grass cover coming in. And I went in, visited those sites yesterday, and you're seeing a lot of lupins coming in, veg. So there are nitrogen fixers that are coming in and doing the work. But you're seeing diversity too. There's a lot of Cidelcia, which is like common checker bloom that's coming in. And I'm not, I didn't see them there when I was sampling. Have they traditionally, like historically been in some of these units? They're the pink flower.
No, yeah, I've seen them in the more open areas, but
But
like
not
this
here.
unit was so overgrown, like you could barely walk through it. And so, yeah, once we're thinning them out, and I've been noticing more.
Yeah, you're seeing alliums. You're seeing more like diversity within the landscape.
For the hand thinning and one prescribed burn entry, was the hand thinning, did they cut and drop everything, or just leave it on the ground and then burn?
Yeah, they lopped and scattered. Tiny. So they lopped and scattered, and when Christy looked at this landscape, she's like, there's no way this is gonna work, because a lot of the times when lopped and scattered is done for the prescribed burn, sometimes it doesn't all consume. But this area had been treated a year prior to the burn, so I think it gave it enough time to kind of cure and dry out. So the lopped and scattered made it look pretty rough, as you can see, but it burned and looks better. But even like madrones, we thought some madrones were going to be like toast, because they got scorched all the way up to the canopy, but they're regenerating. They're having new leaf growth. It's amazing.
I don't have any questions, but I mean, you packed so much into that. And that's just like, obviously a fragment of what you actually done. So I just want to acknowledge that you like were able to distill down a ton of stuff to get it into that format and tell a coherent story. Amazing. Tons of like little points and questions, but like just good job.
Thank you.
All the way.
For future studies, what would you recommend to continue your work, to be gathering more data for those to come?
Unit 2, I think, is an awesome opportunity because I have data before any disturbance occurs, and I didn't really get that opportunity in this study because they've already been treated. I'm trying to develop something, but Unit 2 could be an awesome opportunity for someone. They could just put multiple box throughout that area and just see like, okay, mastication came through. How did that system change, and how does it compare to like first century burn? Compared to this first century burn, and they can compare the two responses. Or another one would be like mastication only, because half of that unit, and I didn't say this in my presentation, but half of that unit was hand thin, but the other half was not. It was mastication only. So I only focused on mastication only because I wanted to see how like one treatment influenced the soil. So that'd be another good opportunity for a student too, to see how like that material laid on the ground affects the soil.
I have that question, I was gonna ask you later, but of the things you measure, because we talked about this early on in the process, like not only making data, but trying to find ways that can be easily applied by others.
Yeah.
Right? So what you did, what would you keep and what would you, because some stuff's burdensome, there's no way it's gonna be implemented beyond your project or project of that side. What measurements would you keep, or what would you think if you wanted to have this scaled out to other sites or stuff like that? What would you recommend it's continued measure?
I would recommend almost everything except hydraulic conductivity, because that mini disinfiltrometer, you can't keep it level to the soil surface if you're on a slope.
Yeah.
So that introduces variability, but there's other methods that you can do water infiltration, like maybe you take out, I've seen it done.
Challenge.
Yeah.
Goes way beyond your projects.
Yeah, and infiltration, not fun. And that's something I would remove just because it's hard and it takes time, and sometimes you have to start over. So if it falls over,
Sure.
you have to refill it, start over, start your time. So that was something, if you're trying to do something faster and get moving, you can do your bulk density. Those are easy. Collect your soil samples. All that's easy. Dust, litter measurements, your my litter measurements, I just incorporated the land or the line intercept. So whatever, if I saw litter, I classified anything that's like not connected to a living, plant structure because it's hard to, I didn't want to be like, oh, this is woody because it fell off a tree. If you start doing that, then you add too much variation into the study, so that adds consistency. So if you see like anything that's not connected to a living plant, you could be like, oh, that's litter. So I'm gonna do that. And then line intercept, I think, was extremely helpful. And that's something I would definitely keep because you're able to see like maybe it influences, if there's too much woody, you don't see that much grass. So I would just hydraulic conductivity, I think, is the one thing I would remove. And I think Joe agrees with that too. That was challenging.
I did it the first day, so I.
Yeah, You were getting so frustrated with
Well, no,
it too.
it's just about, well, except even that, so beyond just what's feasible, but do you think everything you measured would be something that's needed? If you're thinking about how that, because even through all y'all's efforts, our efforts, that was a lot of work. So how would that be implemented at a reasonable time rate? Like what would you have to pull out something?
Huh?
What are the things you think that you measured that are important that you would need to keep measuring? That somebody else, your next technician or somebody
I
else
would
can measure?
Really want to be able to see like more CN ratios.
So
If
soil stuff you think so?
it's still, because we know soil like sometimes doesn't change initially and you don't see a system within a change within the system right at the beginning. So you can see it like 5, 6, 7 years later. So we have continuing like more information on just like nutrients. That's something I definitely want to see over years, just to see like how the story changes.
Is there anything that you would add? Like, is
No.
there something that you thought that like, oh, I should have added this to like make it?
Maybe like, or like your iron, magnesium, more of that like information, just to see how maybe the grass influences some sort of chemical. Like maybe you see a higher raise in magnesium if you burn a tree in this area. So just more chemical information, I think, would help tell the story, because a lot of my chemical analysis, it showed some change, but it wasn't anything big. It was disappointing because I thought once I got that, I'd be like, oh my gosh, this is totally telling me a story, but it was not the case. I think it made it difficult. It made me stressed out more. It didn't really change much. And I kept having this conversation with Kristen. I'm like, I don't know what I'm trying to tell now that I don't see this crazy change. So I would add just more chemical analysis, because that's something that's easy. You just collect your soil sample. It's expensive though. That's the thing. It's pricey, but that's something I would definitely add.
Do you think moving forward, you might use soil properties? I mean, you're always gonna be looking at fuel, but maybe using soil properties as like an indicator of like, this is what our regime should be for burning multiple, because you're saying the ant that multiple burn, maybe it does for some, right?
That's for this study, yeah.
Yeah.
But you don't know until you see it in the long run. It's like in compared to other treatments,
Yeah.
once you start seeing disturbance, because you might see mastication and you might see like a load of carbon is going to be crazy because of all that material. So you don't really know the story until you have more data and repeated treatments, because I ultimately think repeated treatments is what defines this ecosystem, because you need that disturbance, and we've let it go so far. Like,
Have you theorized at all about if a wildfire came through and burned the entire study area? Like what would be
Please don't say that.
the most resilient, or like, what do you think would be able to bounce back?
well, the problem is, so around these treated units, there's units that have not been treated. So we noticed that with the Thompson fire that came through. Chrissy spent so much time fixing this one area with a hazard mitigation grant, but the fire came ripping through. It just destroyed some of those areas that she treated, but it did slow down. So after a certain section, once it gets more into the ground, the property that DW owns, not PG&E, you see it coming down. I had to take a jab at PG&E because I looked at that landscape and it's so frustrating, because they can do something about it. You know, they just not doing it because they're making money. But I'm not gonna talk about that. I'm just gonna talk about Chrissy's work. And there's other issues with them too, but it came in and it slowed down the fire and it actually protected this like part of this ecosystem. It's one of the few green spots we have along that forest guard. It's greening up right now, but it still looks ugly. So treatment does, you have to, offices just like by our work area, by Orville, by the spillway, if you ever want to go there, you will be able to see like, oh, this burned really hot. And then you get to Chris's section and you can see trees, beautiful green. And then the other system just has like blah, nothing. So.
I know you just touched on soil chemistry, but even associated with that is these different methods. It's native versus non-native vegetation. There's so many
That's
things to build off of. Yeah.
Yeah, and that's something I observed, I saw, but it's interesting because the wildfire unit, when you look at it during the summer, and I touched on this on my paper, but you see like, your horseweed and other grasses. But then you go again and right now it's full of lupins. So it's just showing like weather does play a role in it, and lupins are coming in and doing the work, trying to fix the soil, like recover the soil. At least that's how I interpret it. But during the summer, since these soils are well drained, they don't really hold on to water. So everything starts dying off, and then you got these invasive grasses and forbs coming in. And that would be something that I touched on that in my paper, but that's something you should add. But that's just going to take longer if you start identifying species. That could take 2 different students working on 2 different projects. So.
Well, I even think that the treatment method makes a difference as well, because some of them are very ground disturbing.
Yeah.
Or you even have equipment coming in that can track or move things around, steepings and things like that.
And it also depends too, like, did it just rain and we're saying like, oh, this is okay, we can work the ground, we don't see that much disturbance, but maybe in the surface, you're not seeing too much disturbance, but you don't know what's going on below that surface.
Did you take slope into accountability on any of this?
They were all pretty similar. I do have it on my, on the back of my thesis. There are some slope aspects, but most of them were comparable in some size. I think I had one that was maybe like aspect of like, I think it said 30. I need to refer back to it, but one of them was a little bit higher, but like steeper. But most of them were kind of in the same range. Like if you were to do like a mean average.
And I'm assuming like you would get different results like on the different aspects.
North, south, yes.
Yeah.
I know you're thinking about, yeah, you would.
So true though.
Yeah, you will, because it's either about like sun, exposure, you're going to see shifts. You even see it when you're burning, like you see those variations in the landscape based on what direction the slope's facing.
Any last questions?
I can walk away now.
Cool. Well, thank you all for coming. We're gonna meet with Diana and grill her a little bit more.